Alright, the second part of the Revit MEP systems is how to create piping systems. So we're gonna show how to create pipe placeholders, pipe runs, how to add mechanical equipment, fittings, and how to run a layout for pipe system networks, and in an automatic and in a manual way. Okay, so for this we're gonna use the pipe systems file that is in the Blackboard. So we just close anything that we did previously with the coordination file, and we're gonna open these pipe systems. Okay, so I already opened the file here, and we go to project browser, mechanical, so project browser, mechanical, so that's mechanical, level 2 HVAC, so level 2 HVAC is this one, and I just move it here, pipeline. So we are already in that level. Okay, so we go to System tab now, System menu, and Pipe. So we see pipe here. Click on there. Next slide. So in Properties, this is the Properties menu. We go to System Type. So System Type is here. Sorry. System type is here, and then we change that system type to hydronic supply. Click on there. So draw a pipe run, use properties, use the properties shown. So we're just gonna see the slide. So we see the center, justification, vertical, and reference level. So here just put, sorry, not this one, we just go to horizontal justification, center, right, vertical, middle, reference level, level 2, offset 250, we change that, and hydronic supply, apply. So draw a pipe run, use the properties below, and start from grid 4C, so we're just gonna look for the grid 4C. So that's the grid number 4, and that is C. Just to make sure we don't get mixed up, just gonna delete this system that we have here in pink. Just select and delete. So sorry, again we go to Systems, Pipe, and we got the properties already here, the properties that we just input. So from 4C we're gonna create this pipe run that we have in this side of the slide. So let's go. It's as simple as just click, and the red mark is in finishing in grid E. So basically we just finish the pipe run here and escape to finish the command. So we just draw that pipe run. It says finish at intersection with grid E, so that's what we did. Next slide. So go to project browser and families. So go down to families, right? piping system. We look for piping system. It's here. Hydronic supply. So piping system, hydronic supply. Hydronic supply is here. And we're gonna edit the graphic overrides. So basically what it does, so we go, that's graphic overrides. Click in edit. And then if we do changes, say for example now the pipe run is shown in blue. So we can actually change that to be a different color, different thickness of the line that represents that pipe run. So for example, say if we do 7 and change the color to, say, I don't know, green. Okay. Okay. And then we hit on apply. We see how our pipe run change to show that changes that we just did in graphic overrides. Okay, now, well, we compare with the initial pipe. So I just changed the color back to blue. But yeah, you saw just previously how my the actual features of the pipe run changed. So an alternative to create a new system is to duplicate an existing system and to modify it. So basically, if we want to create, right now, our options are of pipe systems are, if I go back to pipe, are all of this. So we got domestic cold water, fire protection, hydronic return, hydronic supply, a sanitary vent. But if we want to create a new system, we just go to edit type and then duplicate. So we have duplicate and we can create another system. I don't know, call it I don't know, hot or condensate. And then okay, and then we can edit the routing preferences, the type of fittings that we want to put in that pipe system, segments and sites, etc. The graphic overrides. So that's what it says here. An alternative to create a new system is to duplicate an existing system and modify it. Just gonna put cancel because I don't want to create that condensate system. But yeah, that's, if you want to create a new system, that's the way you do it. This is just as a general information, mechanical setting tools. So basically, if you go, as it shows here, the picture, if you go to systems and go to here, mechanical settings, click on there, shows you, Revit shows you this window where you can actually set up the pipe settings. In this case, we got duct settings, but we're working with pipes now. So you can say, for example, you can change the system to water or anything. That's for the main pipe, and this is for the branch. And then you can select what sort of predefined or default sizes you want to use for that system. So for example, if you want to use 100 or you want to add a new size, it automatically Revit automatically has the information for internal and inside diameter and outside diameter. So you don't really have to put that information, like type that information, because it's already here. But if you got like a pipe standard or something, like is more say cost like more specific for a specific type of business, then you can create new sizes. But the commercial sizes should be in this table. You can also say, all right, what that's the type of fluid that I want to use. So for water, that's the density, dynamic viscosity, and all the physical properties that we need for calculate pressure drop, and also the formulas that we need that we can use to do the pressure drops. So basically we can compare all our results using 3 different equations. We can also do that. Yeah, so we got all these different capabilities of working with calculations and piping. So that's basically what this slide is all about. We're not going into deep on this area because it's not the subject of this course, but it's always good to know that Revit has this capability to show you that information. Okay, so that other slide is also shows the equations and etc. So now we're going to add in mechanical equipment. So we go to project browser and look for mechanical. So let's go up. Mechanical here. Level 3 HVAC. So we're going to level 3. Pipeline. Okay, so that's our level 3. We are going to zoom to see the south side of the building. So this is the south side, so north, south. All right. And a system tab, mechanical equipment. So mechanical equipment, click. And then properties, so that's the properties, fan coil unit, so FCU. That's actually load already that family, so we're gonna use that family and change the offset to 2800. All right, so we're going to offset here 2800. Enter. Just hit cancel here, 2800, and we're working on level 3. Next slide. So we place the fan core unit as shown. So we see here the grid. This is G here, and we place it here. We see that section view. Is that section view that we have here, and this is the grid G. So G, so it should be here. So we place our fan core unit, say somewhere here. All right. Go to the quick bar tool and section, and create a section as shown. But I already got that section created, so we might not need to do that section again. But if you need to create it, it's as easy as just go to the quick bar tool, which is up here, and then section, hit on section, and we create a section like this just by click and create the section. Actually it's the other way around, so just click here and we create a section. I'm gonna escape because the section is already here. It's created. Okay, it shows here how to do the process to do it. All right, now double click on section view to open it. So we're just gonna escape the command of placing the fan core units and we just double click on the section or right click to go to view, to go to the section view. So that's the next step is align the unit to the ceiling. Okay, so it says we got here the align command. I didn't describe that here because we show how to align before in architecture, but just in case, you know, align command is this one. So you just pick, we're just going to align this fan core unit to the ceiling. Click on here and click here, and we got it. Okay, project browser, again, level 3. So we just go back to the plan view, level 3. And then copy and array fans to feed all the rooms. So basically these fans are going to be the feeding all these 1, 2, 3, 4, 5 rooms. So probably I just get it closer to the room because they're actually getting in to the room. And then we're just going to array this. So array 5 repetitions, 5. And say I just take this as a reference. You can take the door or you can take, but I just gonna take this endpoint as a reference to this endpoint here, or this the center line of this wall, and 5 repetitions. All right. So it created the 4 fan core units. And group the fan core units. So I just select all of them by click on Shift and Shift and click and ungroup. Right. Next slide. So it just shows here all the fan core units. Yeah, we're doing it right. Next. All these, you know how this reads really like these two words are overlapping. This is because of my internet viewer. In the slides, this shouldn't happen. So the slides are actually correct, and also these numbers that they are almost outside the margin. So don't worry about it, Nalim. Okay, now we are going to select thin lines in quick menu. So if we go to quick bar menu, we have 2 options: thick lines like this or thin lines. We originally have it in thin lines, so we just leave it like that. And then zoom in to see the south side of the building. So again, we just zoom in into this area. An accurate location is not relevant for this exercise. So basically, we're just going to create a pipe run, but we don't need to give like a grid location or anything. We're just going to create it anywhere. So systems, go to systems, pipe placeholder. So instead of pipe, we take pipe placeholder, all right. And the fan properties and size as shown. So again, level 3 offset is 2400, and then hydronic supply, copper, and then we go 40. That's the diameter of this pipe. Next slide. So draw a line to represent a pipe run. So we just draw a line. It says that location is not important, so just somewhere. So we're just gonna draw it here. We just draw a line. And follow the same steps 4 and 5, but this time select pipe. So no pipe placeholder, but pipe. So steps 4 and 5, this is 4 and 5. So basically just hit escape to get out of this command. And we're going to systems and pipe. And again, we're gonna create a line here, somewhere here. None of the, that's just a warning. So basically what it happens is we have some problems with visibility, visibility graphics. Basically what happened here is that we haven't changed this offset. So basically we go back here. We haven't changed the offset. So if we see the properties for the pipe placeholder is level 3, and then the offset is 2400. We didn't change that number, so it was minus 3400. So it was doing it, creating the pipe below the ground level, and we need to have an offset of 2400, and then all the rest should be fine. And we try to do again the pipe, and now we can see no problem the pipe. So escape. So create a branch line of the placeholder. But before we do that, we're gonna see this closer. So if we change the visibility settings here to fine, we can see that the placeholder, which is this one, it is still aligned. While the pipe, it actually shows me this geometry here that it looks more like a pipe, that more like not like a line. If we shade, we can see this is clearly a 3D object, what this is still a line. So why should we do a pipe placeholder when we can do a pipe? So what is the difference? That's what I'm about to show you. So we draw branch of the placeholder. So let's go back to systems, pipe placeholder, and we're gonna draw a branch somewhere here. Right. Then create a branch of the pipe. So do the same. Let's go to systems and pipe. Now we're gonna create a branch of this main pipe. Okay. Note the automatic fitting. So look here closer how in this when we did the pipe branch, it actually created the T connection automatically. I didn't have to do anything. Here in the placeholder, not quite. We still have just series of 2D lines. That's a difference. Now, change the run of the placeholder. What happens? Okay, so it says change the run of the placeholder. What happens? So change the run is just basically do a modification to this arrangement. A pipe run is just like a layout that we run for piping. So basically, say for example, we shorten this main line, and instead of being a main line and a branch, we're just gonna do a 90-degree connection here. And we do the same with the pipe. Basically, we just remove this section. So change the run of the placeholder and change the run of the pipe. So what happens? So I see that when I modify this pipe, this layout or pipe arrangement, this fitting, it didn't actually update to become a 90-degree connection like an elbow. It continued being a T. So basically, when you are working on design, many things change during design, and this is just a small example, but this could happen in many areas of your model. So the benefit of working with pipe ducts is if I do this arrangement like just with lines, then it's as easy as just selecting the lines at the end when you are 100% of your or how your design is going to look like and you don't have any more changes. Then you can select your piping and just go to convert placeholder, and then it converts your pipe placeholder into piping. So that's a more efficient way to work. So, okay, now create a branch line of the pipe. So we're gonna create another branch line of the pipe. Let's go here. So pipe and create a branch. And now the automatic fitting, so we got it here. Drag the end of the placeholder branch and change its connection angle. So it says drag the end of the placeholder branch and change its connection angle. So since I converted it to a pipe, I'm just gonna undo this, so we have the pipe placeholder again, and we are going to change the angle of the placeholder, and same thing, we're gonna change the angle here of the pipe. So we see how when we actually drag the pipe, it actually accommodates that fitting to an angle connection. So it actually works when you don't delete components of your piping. You actually modify to accommodate changes. The piping command works good. We need to be careful here because we can manipulate these angles, but of course we need to sort of stick to the standards. So just talking about the angles. But it's very difficult, for example, here to put measure angles when we have pipes like that. So a lot easier when we're working with lines, we can actually just go here to annotate and just take measure of the angles to do whatever is a standard. So I don't know, 45 degrees, or say for example I want this connection to be 45 degrees, so I can easily change this with the pipe placeholder. Sorry, it should be a couple equivalent angles, so it will be 135, I think. So we just modify this to be 135 if that is a standard connection. Disconnect. Sorry, something happened here. Again, so 135. That is good. And then we can convert this into pipe. All right, so that's the idea of pipe placeholder. They provide flexibility in design. So Basically, that's basically the idea. So that's basically all explained here, how with the pipe, if you change the branch, the actual fitting will accommodate, and how a pipe placeholder, if you remove one section of the pipe, it will, when you convert the placeholder into pipe, it will create the elbow automatically. So that's just an illustration of what we did before. Okay, now we're gonna show how to create pipe runs. So let's go to escape here, to escape this command. A project browser mechanical level 3 HVAC pipe. So zoom in to see the south side of the building. So we have this, we are in the south side already and in level 3. And we're gonna create the pipe run using two methods. So the first method, we go to System tab and Pipe, and define a pipe run as shown. So basically it goes all the way across the building, this run here in blue. So first we're just gonna delete this exercise that we were doing. This was just to explain the difference between placeholders and pipe commands. So system types and pipe, right? Define a pipe run. So let's go smaller, and it doesn't have to be very accurate. We just go in here, right? Just gonna run this pipe all the way here, right? Okay, that's the manual way of creating a pipe run. Now, so that's method 1, and then method 2 is select one of the fan core units. So let's go closer and select. Click on this, select this one. Contextual menu, so here, and create system. So which system, create system, which system? Piping, it says here, piping. So name the new system as hydronic system. Sorry, name new hydronic system. So this is a hydronic supply, it says here, if you see in the slide, hydronic supply, as level 3. So level 3 underscore hydronic supply. Sorry, hydronic supply. All right. Okay. So go to Edit Systems. So here, look here in the slide. So Edit Systems, right? And use Control plus left click to add remaining fan core units to the systems. So Control, hit the Control key, and then left click to add the remaining fan core units. So click, that's all the remaining fan core units, this, and this. Click on Finish, Editing System, Finish. All right. Next slide. Select the symbol next to the inlets of the fan core unit. So let's go closer to see the unit. And then when we select it, we see some symbols here. They are actually connection symbols. So they are inlets, outlets, and it says here to click on this, any of these two symbols. So if we it says here select the symbols, so select this one for example. Look how it automatically creates a pipe run which says hydronic supply, which is the system what we just created. So we can just drag this line and connect it to anything we wish to. So say for example if it connects to this main pipe, it does it automatically. It actually creates the fittings and even the elbows for, I think this pipe is below the is one level below this pipe running vertically, so it creates all the fittings for you automatically. We're gonna undo this step, so escape, Ctrl Z, Ctrl Z. All right. Here it says undo a step 4. Actually, Nalin, there is a mistake here in the slide. All we need to undo is the creation of this pipe that we just did automatically. So we don't have to go all the way to number 4. Basically, we just delete that pipe, automatic pipe that we did. Okay. Next slide. So we're gonna learn how to do parallel pipes. So we go to project browser, mechanical, level 3 HVAC. We are already there. So if not existing, create a hydronic supply pipe run as explained in method 1. So just in case someone, I don't know, delete or just someone delete that pipe run, we're just telling them to use the method 1 to create it again. But we already have that run, so it's shown here, so we don't have to create it again. So system tab and parallel pipes. So system and parallel pipes is shown here in the slide. Okay, next slide. Specify horizontal, vertical numbers and offsets as shown. So we go 2 by 2 vertical pipes, and then the offsets are 200 by 200. Sorry, 500 here. So basically it's going to do in the horizontal 2 pipes and in the vertical 2 pipes, and that's the distance between them. So it says use tab key to select the existing main line and create the parallel pipes. So if we stand up, so it shows here what we need to do. So if we go near the existing pipe and we hit the tab command, see how instead of having to grab each section of the pipe, if we just hit the tab, it selects the whole run. So just tap and click, and it selected the whole length of the pipe. Alright, use the section views to see the vertical pipe runs. See, that section view is, we're just using the existing one, so just go to the south of the building. And just gonna use this existing section view to see the, so we can see the vertical pipes arrangement here, but we cannot see the, the horizontal arrangement here, but we cannot see the vertical. So that's why we're gonna use the section view. So go to view, and now we can see our pipes here. Basically they are, the distance that we put between the center lines is too small, so we should go back and let's modify that. So I will undo, sorry, just undid the parallel piping system, and I'm gonna do it again. This time I'm gonna put the distance between the vertical offset, say as double, 1000. Again, tap, sorry, tap, and then go back to view. Sorry, I have to change the not the vertical but the horizontal. Sorry, I just undo this. Parallel pipes. This one, let's leave it as it was, 500. And this one, put it as 1000. Sorry. 1000. Again. So just gonna tap. Oh, sorry, tap. And it created the other pipe system. So again, go to section view. Go to view. And we can see now the piping. We can play with these distances. Right now it is sort of, this pipe is touching this wall. But this is the idea, like how we can do parallel piping. Okay, so next slide. Select the end of one pipe run and drag it. So, okay, let's go to plan view to be able to do that. And we have, say for example, here in the north side of the building, we select this and drag it. It doesn't matter which pipe we select. We just we can also select this one. All right. Now next, undo a step 3. So we just undo what we did. But before that, it says no, the automatic adjust of the fitting. So yeah, the fitting, I'm just gonna put the lines here, shade, so we can see the fitting better. So probably better to put it in height, so we can see the fitting here, how it automatically adjusts to the new angle of connection. So you're just gonna undo that. Control Z. Now it asks me to change the pipe size of a section. So let's change this size here. I just use the same line that we were using before and change the size. So we can change the size in here, edit. Sorry, no. It's actually here in properties. We can change the size here, or easier, just at the top here. So let's change it for a 90 mil pipe and see what happens. What happens, it says in the slide. So basically, Revit automatically create a fitting for a reducer here. So basically, yeah, we don't have to do anything. The actual template, system templates, it does this for us automatically. Or we can go to these mechanical settings that I showed you before to change the default fittings of the pipe run. Undo the size change. So again, we're just gonna undo this and select the pipe end again. So we select this pipe again and go to modify. So modify pipes is already there. A split element. So modify, modify, and a split element. Sorry. Okay. You just see the icon here. It's quite small. Split element. So it's just here. A split element. It shows me the 9 when I click on it. So and split the pipe into sections. So I just select a location. Doesn't matter where exactly. I'm just gonna pick this here, and we're gonna see how automatically it put a coupling. Revit put a coupling and split the pipe into sections. Good. Now, next slide. Select the downstream of the RAN and change its diameter. So upstream and downstream are terms that we use a lot in piping systems. So upstream is anything before this coupling we have. So if we assume that the pipe comes, like the fluid comes from down below the south up to the north, so this will be the downstream and this will be the upstream. So if we change the diameter of this pipe here to anything, so just put 100 for example, we see again that Revit changed that coupling to a reducer. That's more like what happened in real life. You won't install a reducer right after elbow. That's not a good practice, and it's a lot of pressure drop if you do that, and also it's not a typical arrangement. So that's why I put I split that section in two, and then I change the diameter of this pipe here. All right. Now create a branch pipe from the main line. So we're just gonna create pipe here. So that's the main line. So say for example here, and we are gonna create a branch here. Now select the end of this branch. So we're just gonna select the end. This is the end, right? Right click and drag. Right click and sorry, it's not drag, it's right click and draw pipe. Now Lynn, this is something to for you to have a look. So it's not right click drag, but right click and draw pipe. Draw pipe here. All right, next slide. Change the offset to 5,000. So we got the offset here to 3,000, change it to 5,000. So basically what I'm doing here is I am in level 3 and I'm creating a pipe like this branch here is actually running parallel to level 3. But when you draw a pipe, basically you're gonna start drawing that that line perpendicular to the plan, to your work plan. So that's why I give an offset of 5,000, which is I want the pipe to come up 5,000. So that's what I'm doing. Instead of changing plane, go to elevation and draw the pipe, I just want to continue drawing this line as one and that's why I'm doing the offset. So 5,000 and enter. Actually, it's not enter, but it says here apply. So I hit on apply, and note how Revit create this pipe perpendicular and to our main line, and also the fittings. This is a wonderful characteristic of this MEP. So I don't have to waste time doing work planes and then trying to connect one line to another. I am actually working in 2 levels or 3 levels by using this sort of commands. So next slide. Open the default 3D view, so just go to 3D view. In my computer, because I have the link, I am hiding the link, you probably won't see it like that, so I will show you how your view is like in a minute. So basically that's what you should be looking at. That's how it should look in your computer. So basically it's the architectural link file that doesn't really let me see what is in terms of piping. So if I select this link, so check the section view is disabled. So basically if you go to 3D view, check that the section or crop view is disabled. Yeah, it is disabled. Select the architecture link, yeah, and hide. So you just go right click and hide in view elements. Now we can actually see the piping. So tile windows for more detail. So tile windows, we just go to view and tile. Let's close some views here. So I just organize my views a little bit. So basically I go the top, the plan view, the elevations, and my 3D view. I can put fine detail to the 3D view and probably a shade. So we can actually, instead of seeing lines, we can see the pipes, right? This system that we did is in level 3, and it has an offset of 2400. So if we select this line, we see that the 2400, and that's selected here in blue, and it will select it also in the 3D view. So that's, look here, 2400 offset. So we got our piping system. We can actually check closer. We can see our fan core units, etc. So that's actually very useful when we want to work in only one discipline. So basically when you work with link files, you can hide them, and instead of having to hide all the components or architecture, so like rooms and furniture and etc., we just hide it as a whole block, and then we just working on mechanical here. We can also link another MEP file into this file. So say for example if we had electrical and then just hide it as a block. So that's how we work. That's the collaboration part of Revit, which actually fits with the methodology of BIM work. So let's go to the next slide. Go to systems. So it's adding pipe accessories. So let's go to the top view again and go to Systems Pipe Accessory. So Systems Pipe Accessory, which is here, Pipe Accessory. We show the icon here, it's also here, Pipe Accessory. And then load gate valve. So it says no pipe accessories family is loaded. You want to load one? Yes. So we're gonna load a gate valve. So we're working in mechanical, so we just go mechanical folder, MEP. Sorry, piping is not actually here, so I just go back and probably look for plumbing. Better. MEP, features, and then I go valves and say gate valve. So I look for gate valves. I just select this one. So I'm just gonna show here what is the path to go to find these valves. So this is in my computer. It should be the same in the computer at university. Program data, Autodesk, Revit 2017, libraries, US metric, pipe, valves, and gate valves. So we're gonna open that component. And now we got it here. And it says select any existing pipe run. So we just select this one, say, and see how Revit gives the direction automatically. When you select the center line, it says, all right, that should be the location of the valve. It won't let you do it that way, because the flanges actually need to be connecting to each side of the pipeline. Sorry, I just missed my valve. It's back now. So I just click on here and see how the software actually create the space for the valve. We cannot see that connection very clear. Let's go to hidden lines or wireframe, and we can see the connection here, right? But it's not very clear if the pipe section was actually, if Revit cut that pipe section. So let's go into to actually install the valve. So to see this arrangement, we just go to 3D view, and it seems that yes, that if we select the valve and delete it, see how Revit automatically did that gap, and also the reducers. So basically that's all automatic. So that's pretty good. Let's go to the next slide. We are going to learn a little bit about mechanical systems. Okay. So I invite you to read about mechanical systems. I'm going to give a short explanation in class. This video is more to show you the steps, the steps of the practice in Revit. So we go to Project Browser, Mechanical, Level 3 HVAC, and select the fan core units. And create a piping system. So we did that in our previous exercise. So we just do exactly the same. We select our pipe systems with shift and click, and see how it says create systems. We did that with hydronic supply. But we're going to create another pipe system. So create systems and piping. So for hydronic return, so it's already in hydronic return, and we're going to name it level 3 hydronic return. So level 3 underline hydronic return. Edit and add the fan core units. We already add all the fan core units, so okay, they all added. Otherwise we have to edit the system and add them, but by selecting them, all the fan core units at the start, we don't have to edit again. And then repeat the same step for sanitary systems. So basically we select this one. I'm gonna do the other method to add the other fan core units after, so you can see the difference. So we just select one fan core FCU, and then create system, piping, and then it says sanitary, yes, and we're gonna call level 3 drain. Okay, and we're gonna edit system and add to system, and then shift plus, and all the units are in the system now, finish. Right, that's the two methods of creating systems. Okay, so the next step is try to create a new pipe system. So there's no more pipe systems here. So yeah, what happened? Basically, if we go to our fan core unit here, you see, all right, we have the inlet and outlet for the air con, and then we got the drain here, so that's the inlet and outlet for the drain, inlet, outlet, and then we got 1 and 2 more connections. So it's in total is 1, 2, and that's for the drain, which is it is like only one system. So basically we got 1, 2, and 3 systems. We cannot create more systems on this mechanical component. So that's why we don't have the create system option anymore. All right, next slide. So go to 3D view and hide architectural link. Okay, 3D view. Just remember to save your project. I already got this saved on my computer, so I'm just gonna hit cancel. All right, and select one fan core unit. So just here, just gonna select this unit here, and modify tab, modify, and then generate layout. So select hydronic supply. So it tells me. So okay, I'm just gonna explain what we are about to do, so you actually have an understanding before we do this step. So basically, when we creating a pipe system, we might have some idea of where to put a component. So say, for example, a tank. We just put it, say, on the south side of the building, and then we need to connect that tank to another tank that is in the north side of the building. But in between these 2 points, there might be a lot of components, call it mechanical, electrical, structural components that need to be considered when I'm doing that layout. So what Revit does, it gives you the option of creating an automatic layout. So for example, if I were not hiding the architectural link. And you remember how at the start of this chapter I was explaining how to copy grids and levels into this file. Same thing, I can copy rooms, and I can copy beams and everything that I want using the collaborate tool, and then put it into my model, into my MEP model, and then ask Revit to create an automatic layout, which is what we are going to do now. It is a very powerful tool, because when you do it yourself, you might not be considering obstacles of other disciplines. So that's the exercise that we are about to do, just automatic path layout. So we got 3 systems where we are connecting these fan core units. So say, for example, in the slide it says select hydronic supply. So hydronic supply, okay. So what happens? Actually, Revit automatically created a main line and connect all the units with their branches. So that's even more powerful than doing it manually, or using the automatic method 2 that we the methods 2 that we described before. This actually does the whole network itself, but we can actually modify that network. So that's a layout. So it says cycle is in the slide. Sorry, I lost it. Cycle through different layout options. So it shows you here how you can actually cycle through these layouts. So if you go to next, it shows you another way of doing it. Doing that connection. Next one. Next one. And then you select what you like the most, what sort of solution works better for you. You have solution type network or perimeter, and then again you can cycle to the options. So for example, things like that, that's not a viable option. You wouldn't use a pipe spool that small, because it's just not a standard. That would be something you have to work on site to cut this sort of pipe spool, and because you're gonna have your elbows and everything in between, it might be a really small spool. So that's something, that solution is not good for us. And then we just start cycling through all the options, these intersections. That's a different option. So try changing inset settings. So if we go back to perimeter, and then it says inset settings. So let's go closer. And then, for example, just go to the next option and then change the inset to 500. See how this branch changes. All right, try to manually edit the layout. This is in the next slide. So what I did, I just changed the view, and then I set the solution type in perimeter, and then it says try to manually edit the layout. So it shows you the icon here, edit layout. Do you want to override? That's yes. And see how I can actually modify my layout. Just move this main line, move anything, just to fit my design. So yeah, you can actually go as far as you want. I'm just gonna do this, and then basically, if you finish the layout, it just shows you the piping system with all the fittings and everything on it. So you just have to play with it to see what you want to do. And yeah, that's basically the automatic layout functionality of Revit. Okay, to finish with these slides, just giving a brief description of what else you can do with this MEP suite. So you can work in plumbing systems, so very similar to piping. You can add plumbing fixtures. So I invite you to, put wash basins, lavatories, anything, that is actually plumbing. And same, you can work with plumbing or with placeholders. And that's just an example. You can do ventilation, so HVAC is heating, ventilation, and air conditioning. I think I got some ducts here, and you work them very similar to piping. You go placeholder ducts, and you can do duct installation, insert elbows, unions, flexible connections, etc. And that's also another system that you can add to your MEP model. And finally, electrical. Same thing, you got the electrical here, and then you can add lighting, which I think is part of the project, the end project. So for that you need to have a ceiling, so the students need to be aware of that. You can add cable trays, and the model can get as complex as you want. Remember that you can always have link files, as I showed you at the very beginning here, and then just have separate files, but all the disciplines working with a master architecture model. And then if you have a correct understanding of the coordination review process, everyone should be aware of what's happening in terms of other disciplines. So that's the power of MEP, of BIM, and that's why even though the students are working on a civil model, the main objective of this module is that they more than the guys understand, the students understanding what a piping system is like or how it works, is for them to understand that all the disciplines can work together, and Revit has the functionality of it. Thank you.